Welcome to this video tutorial on inverse trig functions. This first video is going to deal in particular with what we call concept 3, when we just have the same trig function with its inverse and we're trying to evaluate what's going to happen. Now the big idea here is simple. Inverse functions cancel and we should just get the same item that we were plugging in as our output. However, we need to be mindful that the item that we're plugging in this scenario actually is in the domain of the indicated inverse trig function. So in this first scenario, our question is 1/4 in the domain of inverse sine? Well, there's two ways you can think about it. First way, is there a point on the unit circle whose y-coordinate is 1/4? Yes. It's not one of our special points, but it's certainly on the circle. The other way you can think about it is just realizing that the domain of the inverse sine is all values from -1 to +1, in which case 1/4 would be in the domain of inverse sine. Is there a point on the unit circle whose x-coordinate is -5/7? Well, yes, because -5/7 is between -1 and +1. It's in the domain of inverse cosine. So our cosine and inverse cosine functions cancel, and we would just get -5/7. Over here, is -7 in the domain of inverse tangent? The answer is yes. The domain of inverse tangent is all real numbers. And if we think about that, on the unit circle, it's true that we can take a y-coordinate divided by an x-coordinate and get as large of a number as we want or as small of a number as we want because the range of tangent is -infinity to +infinity. Same deal would go for the cotangent problem, so don't get caught off guard here. The domain of inverse cotangent is all real numbers, so we should certainly be allowed to plug in +1/8, meaning the cotangent and its inverse cancel. Now down here, if we want the secant to be -5, we want to figure out which point on the unit circle then has an x-coordinate of -1/5, because the reciprocal of -5 is -1/5. That would be our cosine value. Well, there would be a point on the unit circle with an x-coordinate of -1/5. So in that scenario, secant and inverse secant cancel. -5 is in the domain. And by the way, remember the domain of inverse secant is -infinity to -1 included, union included 1 to infinity. But the problem down here with cosecant inverse of 1/2, it will not exist because 1/2 is not in the domain of inverse cosecant. It's not from -infinity to -1, union 1 to infinity. So we can't just simply cancel those functions and say the input is the output. We have to realize that this input's not legit. The other way that we can look at this is it's saying which point on the unit circle has a reciprocal of y-coordinate to be 1/2. Well, that would mean its y-coordinate has to be 2. There's no such point on the unit circle. Next, what if we switch the order in which we're doing the inverse and the original function? So in these problems, we're going to consider that exact scenario. First thing, what angle's coterminal to 16 pi over 3? Well, we could split 16 pi over 3 into 12 pi over 3 plus 4 pi over 3. 12 pi over 3 is just 4 pi. We don't care about even multiples of pi. So in each of these scenarios, we're going to be looking at the angle 4 pi over 3 to figure out what's happening. So I'll draw pictures in for each of these scenarios. I think referring to a unit circle can be quite helpful in visualizing what's happening and in reaching the correct final answer to the question at hand. Again, in each of these we're considering 4 pi over 3 because that's coterminal to 16 pi over 3. Now the other thing that we need to be mindful of is which quadrants do we get an answer. Inverse sine gives an answer in the first and fourth quadrant. Inverse cosine, it's first and second. Inverse tangent, first and fourth. Inverse cotangent, first and second. Inverse secant, first and second, because it pairs up with cosine really. And inverse cosecant would be first and fourth because it pairs up with sine. So let's double back. Over to our first problem. Which angle on the unit circle would give us the same y-coordinate as this angle that falls in the highlighted region? What would be over here, because these two y-coordinates would be the same. So this answer is going to be negative pi over 3. Remember, it has to be expressed as a number between negative pi over 2 and positive pi over 2 to be in the range of inverse sine. Next up, which angle on the unit circle would give us the same x-coordinate as this point? And it has to be in the highlighted region. What would be up here? That would be the same x-coordinate, and that's at 2 pi over 3. Over here, the tangent at this particular spot would be positive square root of 3. Up here would also be a tangent of positive square root of 3, so our answer is pi over 3. Over in this problem, the cotangent down at this angle would be radical 3 over 3, a positive radical 3 over 3. Which angle in the highlighted region gives us the same cotangent? Well, that'll be up here, also at positive pi over 3. Next problem, with secant, we really care about cosine, which is the x-coordinate. So the question is just which angle on the unit circle would give us the same x-coordinate here? That's going to double back up to the top. In this case, that's going to be 2 pi over 3. Make sure you express it as a number between 0 and pi. And cosecant pairs up with sine, which is the y value and the y-coordinate. So which angle on the unit circle in the highlighted region gives us the same y value as down there? It'll be over here at negative pi over 3. So those circles are helpful. Think about where the output must be as far as which quadrant, and also be mindful of the actual numbers that you can have. And then just visualize which angle you care about from the unit circle.